Guys, so in the last video, I got cut off. My phone has been experiencing difficulties, and I haven't been able to record more than 30-40 minutes at a time. So we were left off with 5 equals 4 times 1 plus b. Remember that the order pair, I'm sorry, was 1, 5, and we had discovered, or we had to determine that the m was the slope at 4. So if we work out the problem here, we are left with 5 equals 4 plus b. In this case, we still have to isolate the value of b. So we take away 4 from both sides, and we are left with the letter b here, and 5 minus 4 is equal to 1. So now we have m is equal to 4 and b is equal to 1. So we're going to plug in those values into our original formula of y equals mx plus b, and our answer would be y equals 4x plus 1. Okay? And there it is. Okay, for this next section, 11.6, we're going to be looking at parallel and perpendicular lines. So what we need to do is the following. Okay, what we need to keep in mind, guys, is that it's parallel lines by definition cannot cross each other. And the term perpendicular lines, we covered it at the beginning of the chapter at 11.1 when we were explaining what a Cartesian graphing system is. And remember that perpendicular lines are two straight lines that meet exactly at one point, and they'll make a 90-degree angle. And so the definition, one of the definitions you got to remember is that parallel lines, I'll write it down here, and I'll just use the abbreviation of two lines like that symbolizes parallel lines, and I'll put here have exactly. Okay, so parallel lines, that's what it means. Parallel lines have exactly the same slope. Okay, so there you go. So parallel lines have exactly the same slope. So if they were to ask you a question, are these two lines, are these following equations that those of a parallel line? Compare them. Let's say we have y equals 2/3 x plus 4, and you have y equals 2/3 x plus 7. Then the one thing that you're going to look at to determine if the lines are parallel is if the slope is the same. So in this case, the slope is the coefficient, right? So 2/3 x, 2/3 x. Sorry, I didn't put the x in here. Right? So parallel lines have exactly the same slope. In the contrary, with perpendicular lines have the negative reciprocal of each other. So for example, if I was to say, are these two lines parallel, we'll continue using the y equals 2/3 x plus 4, and then we'll say and y equals negative 3/2 x plus 5. Are these lines parallel or perpendicular? Well, remember, if they're parallel, they're going to have exactly the same slope. If they are perpendicular, the slope is going to be the reciprocal, right? So you would flip over, the denominator will become the numerator, and the numerator will become the denominator, and there has to be a negative in front of it. So now we have 2/3 x, the reciprocal will become negative 3/2 x. Okay, in order for a line to be considered perpendicular. And that's a very straight that's a very straightforward section. That's section 11.6. The one that's going to be a little more complicated, I guess you can say, is going to be the one that deals with inequalities. because as we mentioned last week, we're going to be looking at the greater than or equal to, and also at the either the straight greater than or greater than equal, or straight less or straight or less than or equal to. And for those, we either have an open line or a broken line, because the broken line wouldn't include those points. So let's see. So here's what I'm going to do. Give me 1 second. I'll show you guys my definitions. Okay, so just like I was telling you earlier, Section 11.7 has to do with graphing inequalities. In order for you to solve the inequality, remember that you're going to be isolating the value across the inequality sign, just like we did last week. However, the key thing to remember is that if you divide by a negative across the inequality sign, that inequality sign is going to switch. So if you had y is less than or equal to 7, and you were to divide by a negative, it would become y is greater than or equal to 7. Okay, so that inequality sign will change. You would graph again, you would find the slope, find the y-intercept, you would graph the y-intercept, and you would use the slope rise over the run to graph more points as needed. So let's do an example of that. Okay, so let's say we have this example. Y is less than negative 1/2 x minus 2. So I'm going to be using the blue color to graph that equation so that you can see how you would proceed with that. So again, we always want to start with the y-intercept. So in this case, our first point would be at negative 2. So we go to our number line, or our Cartesian graphing system here, and we start at negative 2. From negative 2, let's look at our slope. Our slope is negative 1/2. So from this negative 2 y-intercept, we go down 1 because the rise went in the negative direction, and it's going to go positive 2 along the run, which is the x. So it'll be 1 and 2 right here. How about if we were to do the following? Remember, if you have 1 positive and negative 2, it's still the same thing, right? So there's only one negative involved in either the top one or the bottom equation. So it's still technically the same. So to find a third point, we would go from this negative 2 y-intercept. You go up 1, right? Because your rise would be positive in this bottom example here. And then you go negative 2 in the run direction. So it'll be 1, 2. And this is what I mean here now. So if you were to see our original equation, it says y is strictly less than. When you have the strictly less than, when you don't have a line under it to imply that it's equal, your line, when you connect the dots or when you connect your points, it's going to be broken because it doesn't include the points in between that. So we'll just go like proceed in this matter. Now, how do you demonstrate that the possible solutions for that problem? Okay, so you're going to demonstrate how is it that you can plot those points and come up with solutions for that inequality. So the way that I always remember is that on which side of the graph are the numbers. In this case, we're looking for numbers or values that are going to be less than that line. So where are the numbers going to be smaller? Are the numbers going to be smaller to the bottom of the graph or on the top of the graph? The bottom, right? So in that case, all of these, and I'm just shading it in like that, all of those points below that graph are going to be potential solutions for that problem. Okay? So again, if it had the less than or equal to, that little one, the little line on the bottom, this line here would be a solid line instead of a dashed line. Okay? So that's the key thing. Let me go ahead and erase it so that we can have it all in the same place. And let me zoom back a little bit. So there we have our original equation is y is less than negative half x minus 2. We proceeded in graphing it. We started at the y-intercept. We went one rise, one down, and the run was positive to the right. Or you could use by switching the negatives, right? To instead of having it in the numerator, we brought it to the denominator. So in this case, the one is positive, and the run will be to the negative side, and we connect the points as needed. Okay, we connect them as needed, meaning that if it's a straightforward greater than or less than, it will be a solid. If it's if it's a greater than or less than, it will be a non-inclusive, which means that it will be a broken line. And if it had the equal on the bottom of that inequality, then it would be a solid as well, because it includes the points that are on the line itself.